The mesa in the center of this scene is located on Lower Mount Sharp and is longer than a football field. It extends more than 110 meters from the leftmost outcrop low on the slope to the right side, where rock debris is behind a light-toned dust-covered dune. The relatively flat foreground is part of a geological layer called the Murray Formation, which includes lake-bed mud deposits. The buttes and mesas rising above this surface are eroded remnants of ancient sandstone that originated when winds deposited sand after Lower Mount Sharp had formed. They are capped by material that is relatively resistant to erosion, just as is the case with many similarly shaped buttes and mesas on Earth. This view shows the dust-covered channels on Tarsis Tholos, which is one of the smaller shield volcanoes on Mars. The main shield is covered by a very thick blanket or mantle of loose material. This is likely to be the same dust that is found across all of Mars. It accumulates on the tall volcanoes because the thin atmosphere at these elevations has a very hard time moving the dust after it is dropped out from the global dust storms. But another reason for the great thickness of the mantle here could be volcanic ash derived from the volcanoes themselves. The flanks of Tarsis Tholos are cut by large channels similar to those visible on other Martian shield volcanoes like Olympus Mons and Elysium Mons. Like the channels on those volcanoes, these channels probably formed by a combination of erosion by flowing lava and the collapse of the volcano under its own weight. However, because of the thick covering, this cannot be said definitively. A striking feature at the northern end of this view is the fact that the dust cover is much thinner on the lava flows that surround the shield. This indicates the surrounding lavas are much younger than the shield and the mantle on the volcanoes is old. A titanium sample tube containing a rock sample is resting on the red planet's surface after being placed there by the Perseverance Mars rover. The rover deposited a total of 10 tubes at this location called Three Forks, building humanity's first sample depot on another planet. The depot thus marks a historic early step in the Mars sample return campaign. Perseverance has been taking duplicate samples from rock targets the mission selects. The rover currently has the other 17 samples, including one atmospheric sample, taken so far in its belly. Based on the architecture of the Mars sample return campaign, the rover would deliver samples to a future robotic lander. The lander would in turn use a robotic arm to place the samples in a containment capsule aboard a small rocket that would blast off to Mars orbit, where another spacecraft would capture the sample container and return it safely to Earth. The depot will serve as a backup if Perseverance can't deliver its samples. In that case, a pair of sample recovery helicopters would be called upon to finish the job. This incredible view shows Phobos setting behind Mount Sharp. The small irregularly shaped moon has a mean radius of just 7 miles and it orbits 3,700 miles from the Martian surface, closer to its primary body than any other known natural satellite to a planet. It orbits Mars much faster than Mars rotates and completes an orbit in just 7 hours and 39 minutes. As a result, from the surface of Mars, it appears to rise in the west, move across the sky in 4 hours and 15 minutes or less, and set in the east twice each Martian day. Sand dunes such as those seen in this view have been observed to creep slowly across the surface of Mars through the action of the wind. These are a particular type of dune called barken, which forms when the wind blows in one direction for long periods of time. Barken dunes are common on Mars and in the desert regions of Earth. These barken dunes are located on the western rim of the Hellas impact basin in the southern hemisphere of Mars. The area is covered by extensive deposits of layered rocks that were initially deposited as loose sediments and over time formed these rock layers. Portions of these layered rocks were subsequently eroded away and the remaining layers now form numerous flat-topped hills called mesas. The barken dunes here are forming in the downwind of the mesas. Scientists have been carefully observing these dunes for many years because they can reveal the speed and manner by which dunes move across the Martian surface. This information can be used to study the current atmosphere of Mars, the age and mobility of sand deposits on the planet's surface, and the hazards that sand dunes may pose to landed vehicles such as rovers.